We're the Water Engineering Associates working on the San Diego State Mission Valley Campus Alternative Water Study. This project was designed for San Diego State University as well as the City of San Diego. Our mentors being John Prince and Sean McCarty here at San Diego State. And our design team consisted of a mixture of civil engineering professionals as well as environmental and construction engineers. Our project location is at the intersection of the 15 and the 8 freeway on the current Qualcomm Stadium lot. Existing conditions were assumed to have developed the recycled water and the pure water lines on campus. This scope of the project was to design water and research alternatives to get the water onto campus, not necessarily designing the pipelines on water, but just getting the water to the campus. So we were designing and researching layouts for potable and recycled water usage, such as drinking water, irrigation, fountains, cooling towers, dual plumbing, and the Mission Valley Terminal. This proposed pure water layout, the demand for the pure water was 2 million gallons a day. We're pulling the water from the facility prior to the pumps that send it to Lake Murray, using two 30 horsepower pumps. One's a backup, one's operational. The water gets put into 12-inch pure water lines that are brand new and being tunneled under the San Diego River using the existing tunnel. And it gets tied into the existing Mission Valley network. There's a ductile valve to prevent the backflow of the water flowing back into the lines.
Stop that.
Yeah, so the water's coming this way.
We'll describe the major areas for potential uses of water. Uses were split into categories based on alternative source water. Our alternative 1 was recycled water, alternative 2, pure water, and alternative 3 was water that could be reused. In our alternative 1, we had recycled water, which the demand was 2 million gallons per day, and recycled water could be used for our cooling towers, our irrigation, dual plumbing, and fountains. For alternative 2, pure water could be used for potable uses such as housing, stadium, retail, campus, and hotels, as well as an innovation we were proposing for a homeless sanitation station and the Metropolitan Transit System. For alternative 3, our reuse could be from the cooling tower blowdown, which could be used for irrigation and fountains. And finally, we would have additional source water being used for municipal purposes, fire demand, and a backup source of water for the Mission Valley campus. Installing a dual plumbing system will allow our campus to operate its water more efficiently. Dual plumbing will use disinfected reclaimed water to provide water for toilets and urinals, as well as additional water needed for irrigation. The price of installing dual plumbing is not considered in this proposal. An assumption is made that the dual plumbing systems have already been installed, and it was determined that the best cost approach would be with dual plumbing and using pure and recycled water.
Additional uses that we accounted for on this project were the MTS trolley station that will be on the SDSU Mission Valley campus. We calculated that the trolley station will use around 39,933 gallons per day of water. In regards to irrigation, we have multiple different uses that we calculated daily gallon per day uses for, including soccer fields, the main football stadium, baseball fields, parks, and landscaping, and that totaled to 267,000 gallons per day of water. And lastly, for our innovation, instead of having a recreational facility such as a water park or something like that, we chose to make a homeless sanitation station, which will include multiple showers and restrooms for the homeless population in the San Diego area to use. This will promote a better health and hygiene standard around the SDSU campus.
So in the next section, we'll talk about the cost for this project. The cost analysis for this project, we decided that there were two main components: the capital cost and the actual water rates for the two options that we decided to run with. One being 100% of the potable water for SDSU being provided by the city of San Diego, and the other being all of the potable water being provided by Pure Water. Since there was no other feasible option to provide SDSU Mission Valley with non-potable water, in both scenarios, non-potable water is supplied to SDSU by the city of San Diego via its recycled water.
This table here shows the capacity charges if the water is supplied by the city of San Diego. It was assumed that 4 8-inch master water meters would be used from a water system analysis prepared by Dexter Wilson Engineering. The total capacity charge came out to be $1.1 million.
The capital cost associated with the Pure Water is shown here. Really, it's the cost of materials and also the cost of construction for the pipeline that would be needed to get pure water from the Pure Water facility to SDSU Mission Valley. The materials can be seen here. What is also included in the capital cost for Pure Water is the permitting that is needed to get permission from the city to use a tunnel to get under the San Diego River back over to SDSU Mission Valley. So here is shown the capital costs that we came up with. Pure Water is more based on the materials and construction that's needed. Construction for a water pipeline comes out to around $2 million per mile, which is approximately what we had. Below that, you can see the table for what it costs per day for all of the water rates. We got these from various sources that can be found in Appendix 5. All of these we decided to equalize in the year of 2020 to get a good starting point for each of them. As you can see, the potable water from the city is more expensive than pure water, and the city needs to pay around $11,000 a day to import this water.
This graph is a better way to visualize how the pure water system would become a cheaper option over time. The blue line is the cost to buy water from the city of San Diego, and the red line is the cost to buy from Pure Water. As you can see, at the year 2034 is the break-even point, where it becomes cheaper for SDSU to be buying water from Pure Water.
After this, not only will SDSU be saving money, but the city will save money by not having to import any water. This all comes together in a win-win scenario where the city saves water, the city saves money, SDSU saves money by buying it at a cheaper rate, and Pure Water gets more exposure for supplying SDSU with high-quality water at a lower price.
WEA's final recommendation for this project is to pull 100% of the potable water from the Pure Water facilities and 100% of the recycled water from the city. The rest of the water in the system will come from cooling towers, blowdown being put back to the system. The final recommendations for the layouts is to include the pumps and the pipe layouts that we mentioned earlier in this presentation.